All right, hi there. I'm Gus Brocchini, and I'm going to be talking about my project, my risk project, which is Introspective, Explainable ActionAdvising on a Budget. So let's start with what ActionAdvising is, which is it's a method for transfer reinforcement learning. So reinforcement learning, you have an agent interacting with environment. Transfer learning, you have a teacher agent and a student agent, and the teacher has knowledge and the student doesn't, and you want to transfer that knowledge into the student. And ActionAdvising does this by, at each time step, the student announces what action it's going to take. And then the teacher decides using some heuristic function whether or not to issue advice for that, for this state, and correct the action. And there's some different heuristic functions. One of them, like a common one that's actually used, is called early advising, where you just issue advice all the time, and then until you run out of budget. That's where the budget comes in. So there's this constraint on communication. And it actually works really well in reinforcement learning. And part of the reason is because it helps the student learn more in these more expert states, right? States that it's more likely to encounter when it's an expert, right? If you think about a car, a normal student is just gonna be learning, like at the beginning stages of training, learning what to do after it's already crashed into a tree, or like as it's like on the shoulder. Whereas a car that's being advised is gonna be in the state where it's actually driving on the road a lot more often in this early stages of training, which then hopefully will speed up training later by exposing it to more of these samples. And so a natural extension is to try to get into advice reuse, right? Because try to get more bang for your buck, bang for your advice budget, I guess, right? Mimicking human students who will obviously, if they're advised to do something, will sort of understand why and then do it again in similar situations. And the naive approach is to just store states and then take the same action that you were advised. But this doesn't scale well to large state spaces or continuous state spaces where you'll rarely, if ever, encounter the same exact state again. So instead, there's a new method called Explainable ActionAdvising, which issues an explanation along with the action. And that explanation comes in the form of a path down a decision tree. So whenever the student encounters a state that satisfies that same path down the decision tree, it can take that same action, or it can confidently say that's what the teacher was advised. And that's great because it allows reuse of more bang for your advice budget. But there is a little bit of a danger in that in a common transfer learning scenario, your teacher is trained not on the exact same task as the student, but a slightly different task, right? Like the car analogy, maybe it's driving in California versus driving in Europe. And if the teacher is meant to systematically bias towards these expert states, but the teacher itself is not quite an expert in the scenario, there are going to be states where it's systematically biasing the student away from expert states towards these like non-expert states. And that can actually be worse than with regular action advising or with no action advising at all, especially with explanations, because if you're repeatedly taking these non-optimal actions, it can really delay learning and exploration. So my project is to try to fix this, or ameliorate it at least, with introspection, where the teacher can examine its advice and try to figure out when advice is bad and then not give that advice, or if it's already given that advice, retract the explanation, say, hey, earlier I didn't know what I was talking about, do whatever you want. And the way I've thought about doing this is using the student's experience in its environment as offline RL data for the teacher. So the teacher can evaluate its TD error at each step, and then aggregate the TD error along the leaves of this decision tree. And then if there are certain explanations, which are just leaves, right, just paths down the tree, the teacher can realize, like, okay, this explanation has consistently, like, the reward is way different than what I'm expecting. The TD error is super large, and not give that advice. And so now you're probably asking, oh, Gus, I'm sure you have these wonderful results that show that introspection is super helpful and solves all the problems of explanations. And that I do not have. I only have very, very preliminary results, which I got about, I guess, as I'm recording this, 45 minutes ago, so I haven't totally thought them through. But here they are. And the main conclusion here is that this theoretical danger does exist, right? There are these cases where explanations can decrease performance compared to action advising or even compared to no advising. And in this case, I was using alternating advising, which is a paradigm of issuing advice at a set interval. So in this case, every 5 time steps. And there is, maybe if you're really looking for it, you can see maybe, there's some improvement from the introspection. But I haven't done any tuning of the hyperparameters or anything, so I believe that the introspection will actually help in the future, but for now, these are the results I have. Thank you, and if you have more questions or want to talk to me about more results, which I hopefully will have slightly more of an idea what's going on by the research showcase, come see me. I'll be there with my poster. All right, thanks.